Okay, that is our topics today. Are you okay, everybody?
Okay.
Okay. Let us start our session this morning with a moment of silence and remembrance of our God. Al-Fatiha. What is the relationship? The first relationship is we have to understand is by the relationship that we already know. We already know is what is relationship because we don't dig that one. We don't do that asking on our own. That's why we are not confident. That's why we are not confident. That's all. Uh, the first relationship is how do we get the value of modulus Young? Uh, Remember that we have learned that modulus Young in solid one, right? Are you with me, guys?
Yes.
And then we go at the back of the books. There's a properties of material. What is E for solid? For steel?
200, if I'm not mistaken.
Around 200 gigapascal. What is the modulus Young for aluminium?
100 something.
No? Somebody else? Siapa masih ingat? 70, yes. You go back at the back of the books, there are properties there. See that? The back of the books here, the back of the book, there's a properties of material there. This is the properties of material. See that? The first property is density. The material we have there what? Aluminium, and then cast iron, we have a copper, we have magnesium, we have a steel, titanium, and a lot of other things there. And then the first property is density. And then the second property is modulus. Modulus of elasticity. So modulus of elasticity is what? Modulus Young. The E. And then the second one is modulus of rigidity. What is that? The G. The properties under torsion, under shear. And the properties under axial is E. And then we have a yield strength. And then we have a ultimate strength. And then percentage of elongation. And then we have a Poisson ratio. And then we have coefficient of thermal expansion. So these are all properties of material. So if you look there, at the back of the book there, so there are properties of material there. And the modulus Young for aluminum is around 70, 73. For copper is around 100. Yeah. And the steel is around 200. Some of them 190 plus, some of them 208, 200. So are you okay with me, guys?
Yes.
So, so those are the properties of material E modulus Young. How do you get the properties of E? Somebody still remember or not?
Sigma times E, shear times stress.
No.
Strain.
No. What is that? It starts with a simple test in the lab. For solid one, there's a test. When we pull it, pull will load there, pull will load there. What happened when we pull it?
The, the, the item elongate and then until it
Yes.
breaks.
Okay, wait. Elongate first, right?
Uh,
So when I put some P there, P, there's elongation, there's a P1, there's elongation, delta 1, right? When I increase that one, when I increase some more, what happened? Increase the P, the delta, the increase the P, the delta also increase, right? Increase the P, the delta also increase, right?
Yes.
Increase the P, delta also increase, right? So these are what we do in the lab. When we increase it, the load, until certain time it break. So just look at that P and delta there. Sometimes break somewhere. So the graph that on the elastic, this is elastic part as a plastic part there. The graph on elastic part there. So we have here is delta elongation. Delta elongation, that means in mm, very small. Millimeter or micrometer, whatever it is. P is in Newton. Are you with me there?
Yes.
Okay, now there's a cross section there. So the P divided by cross section, what do we have?
Stress.
Stress. And the delta divided by the original line, what do we have?
Strain.
Strain. Normal strain. Normal stress with normal strain, we got the same graph not?
Yes, the same graph.
The same shape graph. The value different but the same shape. See that? What is the slope of that one? What is the slope between stress and strain?
E moderation.
That's it. That's the E. Okay? That is the definition of E. The slope of the elastic part of the material. So stress divided by the strain, normal. We got the normal value of properties. The normal value of properties, call it modulus of elasticity. This is elasticity here, or modulus Young. Okay. Some of them are E200. Some of them, let's say the steel is 200 gigapascal. Giga Newton per meter square. Giga 10 to the power of 9. Yeah. See that? That is E. Some of them is 70. How do we draw these two graphs there? This is for steel, this for aluminium. How do we draw these two graphs there? So let's say this is 70. This is 70, aluminium. So you think the 200 gigapascal, where is the graph? More steeper or less steeper?
More steeper.
More steeper must be that way. Are you with me?
Yes.
Okay, this is the meaning of 200, this is meaning 70. So this one been missing with you when you are learning. You are not challenging your brain. You are not challenging your akal to understand this. You just know 270. There's no urge. Tak ada kehendak pun dalam diri kamu, tak ada niat pun diri kamu nak tunjukkan 200 dengan 70 ni dalam graf. And this is what I call, you never have that urge in yourself to show this one too. Because you just read and put it back numbers. You don't know what the meaning of 270. You never do the comparison. This is what I call, your akal is not alive yet. Are you with me?
Yes.
This is what I want you to change. As an engineer, cannot be a follower, just a 270. You don't know why 70, 270. What's the difference there? The question, what's the difference there is not is with you. If the question is not with you, you are not an engineer. Change that. I can only suggest to you. You think you are a good engineering student? You are not changing from Form 5 character to engineer character. The university part is the process of changing your character. You are not changing your character to the engineer character. You are still believing the Form 5 standard of thinking, which is memorizing only, reading and memorize. You're not going anywhere. Are you with me?
Yes.
So change it. So after you'll be able to plot that 270 gigapascal slope, and now you ask. Try to ask question from that graph. This is less steeper. This is more steeper. So how to challenge yourself to create question from that?
What does
This
it...
is say what?
No, nothing. Doctor, say first.
No, I just want to learn. I want you, all of you, to learn, you know. I want to teach you how to develop your thinking skill. You are with me less than 10 weeks more. After this, nobody will teach you how to use your thinking skill. This is the process. It's very expensive, you know. You have an expensive thing in you, but you don't know how to develop it. To develop it, you must open it by question. Now try to develop question. Come on, guys.
What does more steeper or more higher value means for E?
That's the main question. So how to prove it? You see that? Your question, I answer with another question. That is thinking. I understand your question, but I want to go more deeper. But the answer is another question. That is ingenious. Are you following me not?
Yes.
So my question is, this is more steeper, this is less steeper. So what if I want to understand both of it? So what if I do the test? Same length, same size. Same length, same size. That means the cross-section area is the same, not? Yes. And I put the same P. So this is 100, and then the length size. Only this is steel, this is aluminum. And then you ask question. Try to create question from that.
Which one elongate faster?
Not faster, longer.
Longer.
Which one is elongate longer?
Aluminium, of course.
So the answer to that is aluminum, of course. And then how can I prove from the graph? So the 100 divided by the stress, the area, 100 divided by the area, the same stress, not?
Same stress.
So at the same stress there, see that? Here. But the elongation still is less. The delta still divided by L, E still is less. And then the delta here is more. So the delta divided by the E by the L is more for the aluminum. See that? The same stress there, but elongation is more. So I can call it aluminum is softer than the Steel. Can I conclude that? Aluminium is softer than the steel. Softer means easy to elongate. Easier to elongate. Are you with me?
Yes, doctor.
This is what you should do when you learn about this. But nobody is doing this to understand. Just waiting for my explanation. The explanation. But you yourself never dig. That's why you are not going anywhere. We teach you about this. Sigma and thread. You never develop this. You just stop the slope. I told you, your akal here, your brain, have 7 levels. 1, 2, 3, 4, 5, 6, 7. You conclude is number 7. Number 6, you must compare. This is comparing. You never go up there to use your brain. Analysis. You do the graph. That's the analysis for you to compare. Number 4 is apply. You do the testing. Number 3 is digging. Understanding, to dig. No, you try to understand why stress, why strain just now. And then you try to apply it. Or you got the stress and strain. And then you analyze it with 2 different graphs here. I want to compare. So you're doing number 6. Are you with me, guys?
Yes.
This is what lacking in you. I haven't seen this type of student for more than 20 years, you know. The education system has been corrupted. Make you just a follower. It's a shame for the country. It's the shame for the whole world. People are just follower, doesn't know anything, doesn't want to dig anything. That's why all the money are being wasted. Because all the boss there are just a follower to a system. Cannot think, they cannot differentiate, they cannot evaluate. Am I doing this okay or not? That question doesn't come. Is there any other method which is more better than this one that I use? They never come to that stage. Are you with me, guys?
Yes.
They never have the characteristic to dig. What's the problem? Just see, it's a problem only. My son has a flu. Just a statement only. My daughter has a not good in mathematics. That's all. They never dig to find the root of the problem. They never have the capability. Who has the capability? People who has thinking skill. You develop it now during your class. Only then when you are an adult, you can use it in your life. As an engineer, as a mother, as a father, as a kid, as a citizen. But most of them never learn how to develop their thinking capability. This is what happened. Okay? We go further with this. This is easier to expand. I call it the term softer. Just now, right?
Yes.
Aluminum is softer. This is less softer. So what if I put another question? So aluminum is softer. This Steel is much more what?
Harder.
Harder, hard. So how hard is that material is how difficult it for it to
Elongate.
elongate. So you can say that rigid or hard or harder or rigid, more rigid or more hard material is the higher the E. So E is a measurement of how rigid it is, how hard it is. That is the conclusion. Are you with me?
Yes.
Less difficult, more difficult to expand. The more and more difficult is the E must be higher. That's the definition of E. You can imagine that by that graph. You put see that? Put another 300 So at same strand there, the strand is very small. Elongation very small. Less the E, more deformation, more deformation there. More deformation, the same stress. So you can conclude. So E is a measurement of how hard or how rigid is the material. That's how you conclude with number 7. Just now, you just know the name modulus Young. What is modulus Young telling you? You just remember back. Still forget already. Do the stress strain, the slope. None of you is answering just now. When I show you this one, and then you come to you. And then inside that one is the one. Can you see now how poor is the learning skill of most students now? Can you see now?
Yes, can see.
This what, when I was young, about 40 years ago, 35 years ago, when I was in student university, this is what we do in the library every single day. We discuss it. What is this actually? It start with the discussion start with question and question and question. What is this modulus Young actually? It's not just you get the note of the name modulus Young and then you finish, go home, you finish. We do the digging the question and we read the book and explain it, try to explain it with your friend in the library. What time is that? We never go home from 4 o'clock until 9 o'clock at night. That's how hard, how true is the older student. When we were a student, we study because we want to understand. Not we want to do the test. You don't even understand what is the definition of E. And then you are, sokono je nak buat test. Because just remember the formula. See that, the character? This one I want to, I can give you the story only. I can only give you the comparison. What's the previous student and the now student. It's up to you again. You want to develop or not? You want to manage your time or not? You do the exercise and then you don't care to dig that exercise. Because this is typical. 99% of students is like that. Now, previously, 99 students are doing what I told you just now. Now, 99% is the other way around. 99% of students don't know what to do until being asked. There's a lot of questions to ask. They don't know what to ask. When they say the E, they want to finish that one. They never dig to understand what is E. This is not higher level. Start with number 3 just now. How do I understand the E? What if I do the testing like that? That's number 4. Apply. What I compare this one? That's number analyze. Do a different graph for E 70, 200. And then I do number 6, compare. How do I compare this one? Oh, the same stress, the same load. That means the same load with same area, same stress. Or same stress there, but that one elongate more. That's how you understand. Without doing this, you don't know anything. After you do that, your confidence is much more, right?
Yes.
This is the difference. Oh, the E. Oh, the E is just a measurement of how hard or how rigid is the material. The more rigid is more difficult to expand. That is number 7. Conclude. This work have to be done by student. On your own. What is the key? Question with another question, another question, another question, until you go up to the 7th level of your capability. Only then you are confident. Okay, can you please change your habit? I show you how to study. I show you how to study there. Everybody, how many of you now? 50 students. Do that. You do the normal study that you have been doing, you're not developing your intelligence. Believe me, you are developing your memory only, up until number 2 only. Your memory is not your intelligence. Just a lower part of your intelligence you can memorize. After that, what? After that, what? After that, what? That's your CPU. That's your akal. That's your intelligence. Your akal know how to make a decision. Just until memory, you don't know how to make a decision. You don't know how to conclude. Are you with me?
Yes.
If you record my speech today, you, whoever record it, use it forever for your life. If you want to teach your kid, if you want to teach your whatever, your brother, your sister, this is the real method of learning. Believe me. If not, you're not going anywhere. Okay. Okay, now, these are the main relationship, right? Okay, let's look again. Our titles today is the relationship between stress and strain. Yeah, we know the relationship. Yeah, stress over strain is equal to modulus Young. Now, go further. You brought the experiment that you do. So I put the stress in X. That means the stress is sigma over area. So I got the strain in X. So this is X. This is EX. That's much you understand. If I pull in X only, I cannot say this is E in Y. The strain is in X. The stress in X direction. The strain is also in X direction. So the E must be the properties in that direction. Because there's no Y there. Now, then you ask again. So, if I pull this one, what happened to this? This one elongate. What happened to the diameter? See that? Again and again, you asking yourself, what happened to the diameter? Now you ask. After you ask, what you answer?
The diameter smaller become.
Is there any stress in the Y?
No.
No. But the diameter, the strain is there. Because become smaller, the strain become negative in Y. So how do I relate it? Question come again. So if I draw the element like that, you know, the strain, element become elongate, that is EX there. And then EY is negative there, F value. This is how confident you. This is the experiment diagram. This is the element diagram, the original, the new one. I know my EX there. The stress diagram is just like that, sigma X. There's no sigma Y. The strain element is the original one, the new one there. My EX, I know the value. It's positive. I can calculate the value. Because this one, what is EX there? I use this one, put the other way around. What is that? EX is equal to sigma X divided by E. Can you see that?
Yes, can see.
So if I don't have a measurement device, to measure the elongation, that one, I have a theoretical value. What's that? I know the load there. I know the load, I know the stress. When I know the stress, can I calculate the strain? Yes, because the relationship is like that. I know the stress, I know the property of material. Can I calculate the stress, the strain? Yes, I know that one. What about this one? What about this one? I don't have any stress in Y. And then you go and ask again. What are other relationships that we know? That is Poisson ratio. Remember that Poisson ratio? Anybody remember not? Poisson ratio.
Remember.
And your properties of the book just now have Poisson ratio, right? 0.3, 0.33, right? So
Yes.
how do we get that Poisson ratio? Poisson ratio is the properties of material, sifat semula jadi bahan ni. What is that Poisson ratio? Question with question. What is that Poisson ratio? The formula say Poisson ratio is EY over EX. Or in the book, minus E lateral over E longitudinal. So this is 0.3. So this is longitudinal. So this is longitudinal. So your X is longitudinal here. EX. So if I put that one the other way around, put this one the other way around, what is EY there? EY is equal to minus Poisson ratio EX. Correct?
Yes, correct.
So if I know that EX is 10, how do I get this 10? 10 microstrain. Let's say 10 microstrain. From where? Sigma X divided by E. So can I put here? This is 0.3. Then that is 10. So this is minus 3. Can I calculate EY not?
Can.
See that? Try to understand it. This is what the meaning of Poisson ratio here. See that? See that? You put in X longitudinal. I want to find how much is going down in the Y. Going down in the Y. So EY is equal to minus Poisson ratio EX. So this is the characteristic. 0.3. If that is positive, if that is 1 here, this is 0.3, this one is negative 0.3. That means if I pull this one 10, this one coming in 3. If I pull this one 100, this one coming in 30. That's the meaning of 0.3. That's why they have a minus in front of that. That's how you explain. Are you with me, guys?
Yes.
I pull this one, elongate 100. If the Poisson ratio is 0.3, this one will coming in 30. If the Poisson ratio is 0.28, if I pull this one 10, this one will coming in 2.8. If I pull this one, the elongation is 1, this one will coming in 0.28. That's the meaning of Poisson, right? The other way around. Question. What if I push it in? So this one coming in 100, shortened by 100. This one will go out. How much out? That Poisson ratio. 100 coming in, this one coming out 30. That is 0.3. Are you with me?
Yes.
There's no such force in Y. The force is from X only. The stress is from X. But in elongation, the deformation in Y is there. In X, automatically there is a deformation in X because the stress in X. Are you with me? This is how you understand Poisson ratio. Why you don't understand Poisson ratio before this? Because you don't do this question with question, asking and asking to understand it. Why you understand my explanation? Because you have gone through that things, right? But to relate it, you never have question in your mind to relate it. That's what happened. The work of relating it is what we call revision. You do from 4 o'clock until at night to relate it. What is the relationship? How this one is connected to the how that one? Why they call it negative there? Why 0.3 there? Why not 1.3? Why not bigger than 1? Never ask that one to yourself. Because your character don't have that one. Asking character is not with you. The asking character is the engineering, is the engineer's character that you have to develop every single day during your learning. Are you with me?
Yes.
Okay, once you understand that one, so can I develop a question? What is the question? Can I develop the relationship my own? Okay, I have a stress in X only. Sigma X only. Sigma X. So how do I calculate the strain in X? Strain in X, the relationship is that one. Stress and strain, the E is there. So that must be right. If I don't understand, sigma divided by E is equal to E. So the strain must be sigma X divided by the EX. You have the first relationship, right? And then, how do I find the strain in Y? In Y there, EX there, because it's smaller from the Poisson ratio. I know that. EY is equal to minus Poisson ratio EX. So I develop this one is minus is equal to minus Poisson ratio sigma X divided by E. See that? After I do that explanation, I can write my equation. So I don't have to write this one anymore. So it's equal to minus Poisson ratio sigma X divided by E. The same equation by that one, but I have a Poisson ratio in front. Why the minus there? Because it become smaller. This become bigger here. Are you with me not?
Yes.
Okay. Another question come. You can develop this on your own. What if I have sigma X and sigma Y? See that? I have sigma X and sigma Y, different value. So what happened to the calculation there? Question with question. That's how you understand. So the X will definitely give this one. But don't forget, what about the sigma Y? the sigma y will give the elongation in y and smaller in x. So EY must equal to sigma y divided by E. There's no Poisson ratio there, right? The EY here, not this EY, the red one will elongate by this formula, right?
Yes.
And then what about the smaller thing? What happened to EX? Minus Poisson ratio, EY, right? This different thing now. This effect of Y. Here, this effect of X. So I can write this one minus Poisson ratio sigma Y divided by E, correct?
Yes, correct.
So how do I combine? What is sigma X and sigma Y happen to the X direction only? So this and X and X. So what is the total of this? Total of that, EX, the first one must the effect of X. There's no Poisson ratio. Must be sigma X divided by the E. But the other side, sigma Y here also is giving this one in X direction become smaller. So must be the effect of minus Poisson ratio sigma Y divided by E. But in X direction. So this is actually the main relationship. If there are 3 dimensions there, minus Poisson ratio sigma Z divided by E. If no, there's 2 dimensions only, X and Y. So this becomes 0. So this is the main equation. The relationship between X and Y. Stress and strain. What about EY? EY, the first one must be in Y direction. In Y direction, there's no Poisson ratio. Sigma Y divided by E. But the X direction also affect the Y direction. Must be the effect must be Poisson ratio. Sigma X divided by E. So X effects no Poisson ratio. Y effect to X, there must be Poisson ratio and minus that. And then Y there, the Y direction there's no Poisson ratio. There's no negative. And then when is the other X to Y, there must be Poisson ratio. Simple not?
Yes, simple.
The real one, you already understand. You know this one and you know the effect Poisson ratio, but you don't know how to relate. That's how you relate it back. This is the working that we have been doing. I still remember it for the rest of my life when I do this digging 40 or 35 years ago. I never use any textbook. I use my understanding 35 years ago to explain to you now. And that's why I want to show you how my thinking is working. That's why I use whiteboard. I never use the slide. That one. Because I want to show you how thinking is working. Are you with me, guys?
Yes.
So these are the relationship. So you can write the relationship there. What are the relationship? Because this normal stress and normal strain only. The shear doesn't affect the normal. Yeah, what are the relationship? EX is equal to sigma X divided by E. That direction, no Poisson ratio. And the other direction must be minus sigma Y divided by E. So that is the main relationship. You can change it. X and Y is 90 degrees. 1 and 2, 90 degrees not. Yes. Can I change this one? E1 is equal to sigma 1 divided by E minus Poisson ratio sigma 2 divided by E. Can I change this one not?
Yes, can.
Same thing. So E2 is equal to sigma 2 divided by E and minus Poisson ratio sigma 1 divided sigma 1 by E. So sigma 1 is Poisson ratio there. Because this is 2. I can write directly the relationship. This is the main relationship between stress and strain. This is only for normal strain and normal stress. For the shear part, shear part there, there's a tau there, there's tau there. Tau, what is the relationship between tau and gamma? Same thing. Tau and gamma, give a tau there, there's a gamma there. The slope is what? The tau divided by gamma is equal to the G. So the G cannot influence the E. G with G only. Are you with me?
Yes.
So these are the relationship between stress and strain. Normal stress and normal strain. This is the one. So you can write this one. Just remember one. The other is the same. If you don't understand the process of get that one, you are not confident. What is the other equation? What is the other equation? You cannot create on your own because you never create on your own before. Are you with me? That's why you are not confident. What is the other one? You still worry about memorizing it. Are you with me?
Yes.
I don't have to worry about memorizing. I know one. I can write the others. Why? Because I know the process of getting that one. Yeah? E1 is equal to sigma 1 divided by E minus Poisson ratio sigma 2 divided by E. So E2 is equal to sigma 2 divided by E minus Poisson ratio sigma 1 divided by E. See that? Very simple. Okay. And now, so what is the relationship? The relationship involves only two other properties. What are two other properties? You read here, give me. What are two other properties that you have to know to relate stress and strain? Give me, quick. You look here, give me the two properties that you have to know to relate stress and strain. What's that?
E. Modulus Young. And Poisson's ratio.
You must know the E and Poisson ratio. Question again, you ask yourself. To relate stress and strain, you must know the properties. What are the properties? You ask yourself. The properties is modulus Young and Poisson ratio. And so you don't know that two properties, you cannot relate stress and strain. Are you with me?
Yes.
Number 7, you conclude. If I don't know this one, I don't. You conclude yourself. I cannot relate stress and strain. It's how you. Okay. This is what? This is, I know the stress. I can find the strain. This is stress, I know, right? I can find the strain. What if I know the strain? Can I find the stress? Another question comes. I want to reverse it. I do the strain analysis. After to do the Mohr circle, everything, I got E1 and E2. Can I find sigma 1 and sigma 2? That question. This is, I do the stress analysis. I do the Mohr circle, I found sigma 1 and sigma 2. From sigma 1 and sigma 2, I can convert. I can find this E1 and E2. The other one here, if I do the strain analysis, I know it's E1 and E2. Can I find sigma 1 and sigma 2? So what is the question? The same equation here, but I know this one is one. I want to find that one. You can solve that one. Two simultaneous equations. See that? Saya tak percaya cakap. Katakanlah you dapat E1, nilai dia 500 microstrain. E2 is equal to minus 200 microstrain. Let's say your Mohr circle. E1 is 500, E2 is minus 200. Let's say. You got E1, E2, right? Can I solve that equation there? I know your Poisson ratio, I know the E. Can you solve that two equation to unknown?
Can.
Yes. You know that? See that? 500 10 to the power minus 6 equal to, I don't know my sigma 1, I know my E. 200 10 to the power 9 minus Poisson ratio I know, and then the sigma 2 I don't know, and then 200 then. So one unknown there, two unknown, the other one here. Minus 200 10 to the power of minus 6 equal to sigma 2 here I don't know, and 200 10 to the power of 9 minus 0.3, and sigma 1 and 200 number. So two equation to unknown. Can I solve it?
Yes, sure can.
Yes, you can always solve it. Same equation. But to make life easier, can I rewrite this one in terms of the other one? Yes. If you do your mathematics, the one, you can rewrite it back. How can I rewrite that relationship the other way around? What is that? Sigma 1 is equal to what? Sigma 1 is equal to E minus 1 over Poisson ratio square, and then E1 plus Poisson ratio E2. These are the relationship. If you reverse that one, the first one that don't have Poisson ratio, the second one have Poisson ratio. Sigma 2 is equal to E over 1 over Poisson ratio square. Okay? E over 1 over Poisson ratio square times 2 here must be E2 first. And then this is plus Poisson ratio E1. This is what? This one if you reverse it. If you know the strain, you want to find the stress. Write this one in your books. This is not written in your book, that one. This is a backward case. That means from strain to stress. This is a forward case. Forward case is from stress to strain. Forward. This is backward. Are you with me?
Yes.
Can you remember it now? By heart. Okay, everybody, close your eyes. Just from the thing that we learned today. Yeah? Do the forward case. We read it together. What is that? Read it together. On your microphone. Come on. Read it together. What is that? Your E small is equal to, E1 is equal to,
E1 is equal to sigma 1 over E minus Poisson's
E.
ratio sigma 2 over E.
Yes.
E2 is equal to,
E2 is equal to
Equal to
sigma 2 over E minus Poisson's ratio sigma 1 equals over E.
That's how you test yourself. And then the reverse relationship. I want to find the sigma 1. Okay, sigma 1 is equal to
Sigma
E over 1
modulus Young. Okay.
modulus Young over
yang 1
1
over
minus Poisson's ratio square.
And then
over E
Times
parenthesis first.
parenthesis E1 plus Poisson's ratio E2.
Plus, not minus. Okay.
Okay.
What is sigma 2?
sigma 2 equals to 1 over
1 minus Poisson's ratio square, parenthesis, E2 plus Poisson's ratio E1.
See, very easy. So if you do a stress analysis until the Mohr circle, you got sigma 1, sigma 2. Can you find E1, E2? Yes. And then you do a strain analysis until you find Mohr circle of E. And then you got E1, E2. Can I convert to sigma 1, sigma 2?
Yes.
This is what we learned today. Yeah? Where do we convert it? We convert it at the principal direction. 1 and 2. Can I convert into X and Y? Yes. If you convert into X and Y, you require the shear value. If not, you cannot plot the Mohr circle. If you if you convert at the principal value, I don't know. If I don't know the value of shear, it's okay because you know at principal the shear is 0. You can still plot the Mohr circle. Are you with me?
Yes.
If I use x, y there, x, y there, and then another one EY, you cannot plot Mohr circle because you don't know the gamma XY. But but if you use 1 and 2 there, I don't know the gamma. I don't know the gamma XY, but I know that during that principle your gamma is 0. When you know gamma is 0, can you plot the Mohr circle?
Can.
That's the nice thing. You convert it at the principal direction, not XY. You can still plot the Mohr circle. Okay? We do it today. Okay? We do it today. Yeah, look at this. Take a very simple exercise. Yeah? I pull it, the load there. I put the load only X direction. No Y direction, no torsion, everything. So I put a strain gauge there. At 30 degrees from direction like that. I put a strain gauge there. EA. 30 degrees there. Remember that? This is what direction is this? What direction is this? This is what?
X direction.
This is X direction. I put a strain gauge and position 30 degrees from X. Are you with me now?
Yes.
I want to find that value theoretically. How do I do that? So if I put that strain gauge and read the reading, that is practical, right? Practically, experimentally. I want to find that reading theoretically. So can I do that? I can do that from Mohr circle. Look at this. Draw the element from the beginning, stress element, because this is stress. So let's say the stress here is 100 megapascal. There's no Y, right?
No Y.
No Y. What is the shear value?
Here also 0.
Tau XY is 0, right?
Yes.
Can I plot Mohr circle there?
Can.
Yes, Mohr circle of stress, not strain. X value here is what? 100 and 0. 100, 0 here. This is your X. 100 there. 0 there. Tau is 0 there. This is sigma there. And here is 0, 0. Your Y direction is here. The Y direction there. So from Y point and X point there, remember Mohr circle is point, not direction. Are you with me?
Yes.
Draw a line there. The line is 100. The middle must be 50, right? Your radius must be 50. So you plot a Mohr circle there. So your radius is 50. The center is also positive 50. Correct?
Correct.
This is your sigma X. So from after you do the analysis Mohr circle and you understand what is sigma 1.
100.
Same position with sigma X, right?
Yes.
If I draw the element there, X there, I don't have to rotate anything. Your sigma 1 is also there. Your diagram of principal stress is also like that. Are you with me?
Yes.
So your principal direction is your X direction is same point with your 1 point with the X point, right? Same point there. Point. That is the diagram of the element. And I convert into strain. Look at this. What is E1? Again, what is E1?
E1 equals to sigma 1 over E minus Poisson's ratio sigma 2 over E.
Okay. Now, what is the value of sigma 100? What is the value of sigma 2?
0.
0. So put it there. What is that? 100 megapascal. 10 to the power of 6 divided by this is 0. Your E is, let's say this is your still 200 gigapascal. 200, 10 to the power of 9. So what is the value of E then, please? Correct?
500 micro strain.
1 or 0 0.5, 0 0.3, 5, 10 to the power minus 4, 50, 10 to the power minus 5, 500, 10 to the power minus 6. Are you with me there?
Yes.
You have to do this for your understanding, confident. 500 microstrain. Yeah? So my E1 is 500 microstrain. So what is my E2? Equation is what?
Sigma 2 over E minus Poisson's ratio sigma 1 over E.
So what is sigma 2?
0.
So put it there. Minus 0 minus 0.3. This is 100 10 to the power of 6 divided by the E 200 10 to the power of 9. So this is minus 0.3 times 500 microstrain. So what do we have there? Minus 150 microstrain, correct?
Yes, correct.
Everybody, you see the explanation there?
Yes, can see.
Okay. Now I got 500 and I got E2 is minus 150. Now I want to plot the Mohr circle. What value is this? E1 and E2?
Principal strain.
Principal strain. What is the shear strain during the principal strain?
0.
That you must ask that. This one automatic give you your gamma 1, 2 is 0. Right?
Yes, correct.
So when I know that one, can I plot the principal strain Mohr circle? E there and gamma over 2 there. So my E1 is equal to 500 microstrain. My gamma 1, 2 is 0. E2 is equal to minus 150 microstrain. Your gamma 1, 2 over 2 is 0. Right? So your gamma over 2 and straight there, 500 there, and then minus 150 there. Plot a Mohr circle there, 0 and 0, the shear there, the shear gamma is shear 0. Can you plot a Mohr circle like that? Are you with me?
Yes.
This is your one direction. This is your two direction. This is your one direction. This is your two direction. What is your x? Your x is the same as 1. Your x is the same as 1. So you must bring that one. The question is what? Where is your x? Your x is here also. Your y is here also. See that?
Yes, can see.
You just know 1. You don't know y. You don't know x, right? You must put there. Where is your x? Where is your y? Now you go back there. You go back there. There is your x. There is your y. Where is that A direction there? A direction is counterclockwise from x. 30 degrees, correct?
Yes, correct.
Where is my A here? Where is my A here?
60 degree counterclockwise from X.
60 degrees from x there. There's your x direction there. X here. There must be A point there. 60 degrees. When A is there, there must be B there, right? Can I read the value of stress? Yes, because there's stress Mohr circle there. And now I bring to the strain Mohr circle. If the A is there 60 degrees, where is A here?
Also 60 degrees.
Also 60 degrees. So that must be your A then. That must be your B then. So can I read the value of strain then? This is 60 degrees. Yes, because I know my radius. I know my radius. Because this 500, this is 150. Total is 650. Half of that is what? 325. This is 325 here. 325. 325, same with radius. Your radius is 325. 325. And then this 325 is 60 degrees. Can I find this height? Yes. Can I find this length? Yes. What is the center there? Center is half of that. Your center is what? Average of
EX1.
minus 150 divided by 2. What is the value there? 350 divided by 2, 175. So this is 175, that 175, value here. So what is that value? So 175 plus that base. That triangle here have a height and a base. So what is the value of that one? What is EA? What is the value of that one? EA? How to write that one? That value is center plus base. Base there. Base there. Are you with me?
Yes.
So this is how you read that value. That value is that value. Are you with me?
Yes.
That's how you do the analysis from the relationship between stress and strain. So we use the forward equation just now. From the stress to the strain and the strain. So what if we do the reverse thing? Are you with me, guys?
Yes.
What is reverse thing? What is reverse thing? I put a string gauge. I got three value there. I got EA, EB, EC. So maybe I find XY, maybe I'll find A and C. I don't know which one is 90 degrees. Let's say the value here is 500 microstrain. This EB is minus 100 microstrain. EC is minus 300 microstrain. Let's see. Okay? Let's see that one. So, after I do that strain analysis, what do I have? I have an EX. I have my EY. I have a gamma XY over 2, correct?
Yes.
Are you with me?
Yes.
Let's say your value is, this one is 350 microstrain. Let's say. And then EY there, same as that one, minus 100 microstrain. Gamma XY, let's say your value is negative 150 microstrain. Let's see. After you do the formula analysis, that one, you got this one correct?
Yes.
Then the question is what? The question is, this is act there. The question is, what is sigma theta at direction 40 degrees from X? Question. What is sigma X dot at 40 degrees from X? That means 40 degrees there. So what is the sigma then? It's not about strain, about stress. So what do we do? This is what we do, the process of, we finish this one first until you do your Mohr circle. And from the Mohr circle, convert into stress Mohr circle. From the stress Mohr circle, you find that position. Are you with me?
Yes.
You must have that mind first. Okay. When you solve this one, okay, let's say you solve this one. You got this one, do the Mohr circle. Quick. 300 and positive 150. 350, positive 150. This is your X. Your Y is minus 100, and minus 150. So this is your X, this is your Y. Are you with me?
Yes.
Are you following this?
Yes, still following.
How do I get this value? Answer back. How do I get this value?
From strength analysis.
From strike equation analysis, that one, right?
Yes.
Okay, one you got that one, you got a more circle there. So this is your X and Y. What is center there?
And the average of EX and EY.
Give the value. Very quick there. What is the center?
125.
Alright? Your center is 1, 2, 5, and 0, right? What your radius? You don't know your radius first, right? What is the length there?
C plus R.
This is 350. This is 100. What's total length? 350 and 100 there. 100 minus 100. 350. What's total length there?
450.
So half of that is what?
225.
2 to 5. The height here is 150. So what is your radius there? Quick. You are still very slow. Most of you are very slow in understanding the Mohr circle.
Radius equals to 270.
Radius is 270. So I know the Mohr circle now. What is my sigma 1 there?
C plus R.
Center plus radius. What is that?
395.
270. 395. What is your sigma 2?
C minus R.
So what is that?
Negative 100.
Huh?
Oh, negative 145.
Negative 145. 125 minus 270. 145. So I got the value of sigma naught. Principal naught.
Principal.
What is the shear value during principal?
0.
0. So when I got the principal stress there, remember that this is the value here. Sigma 1, 37395. I got a value here, sigma 2, go to minus 145. I want to find my strain Mohr circle now. So I convert from stress to strain. Principal direction. Principal direction, I know the shear is 0. So this is gamma over 2, this is E. This is sigma, and then this is tau. Don't forget that one. I want to find that one and that one. So what is the equation relationship? Remember that? What is E1? Equal to? Quick. Formula first.
Sigma 1 over E minus sigma 1.
Sorry. This is not. This is the other way around. This is E. Remember that?
E.
This is gamma over 2. Remember that? We are wrong. We are doing the other way around. Correct?
Yes.
I want to find the tau and sigma. These are all not sigma here. This is E1. This is E2. So I want to find sigma. What's the formula? What is sigma 1?
E over 1 minus Poisson's ratio square, parenthesis E1 plus Poisson's ratio E2.
And now, plug in the numbers there. Let's say the value is 200 gigapascal. 0.3. E1 is 395, 10 to the power of minus 6. Plus Poisson ratio is 0.3. Minus 145, 10 to the power of minus 6. So this become minus later on. So what is the value there?
.3 megapascal.
Okay. Now what is the sigma 2? Sigma 1 is that one. So the sigma 2 now. So this must be E2. This must be E1. Okay. So this must be E2. E2 is 1 minus 145, 10 to the power minus 6. This must be E1. E1 is positive 395, 10 to the power minus 6. Okay. So what is the value of sigma 2 there?
Negative 5.82 megapascal.
So question come. When the principal stress, what is the shear value?
0.
You must know that one. Your tau xy, tau 1, 2 is 0. Only then you can plot Mohr circle. If you don't know the shear, cannot plot Mohr circle. See that? 77 and 0. Yeah. And then there is minus 5 and 0 there. This is your 1, this is your 2 there. So this is your tau. That's your sigma. And then center there, must be a center there. And then I have more circle there. You must find the center value there. What is the center value there? Sigma 1 and sigma 2. What is center value there?
Center 35.75.
What is the radius? What's the radius there?
I think I balik. The radius should be 35.75.
I don't think so. 77 plus 5 years more than 80, right?
Yes.
So radius must be more than 40. Simple mathematics there. 77 and 5. The line here must be more than 80, right?
Yes. 41.55 for radius.
That's how thinking skill is always asking. Very simple checking. 77 and 5, more than 80. So radius must be more than 40. Correct. So you know that one. Now there's your 1 there. There's your 2 there. There's 1 there, 2 there. What is the angle there? Your x now is there. Your x is also must be there also. What is the angle there before this? The strain analysis. What is the angle there? This Mohr circle angle, 2 theta there. What is that value there? $150 and 225.
33.7.
33.7. So the same angle here must be 33.7, right? The same angle there to show what point? To show what point? To show your x point. Are you with me?
Yes.
To show your x point. So your x, that's the 3, that one is your x. So there's your y. There's your 1, there's your 2. Remember that? There's an E1 there. You start with X and Y, correct? Are you with me?
Yes.
Okay. Now, what is the question just now? You got a strain gauge like that just now, right? Right? I want to find the stress at sigma at 40 degrees from X, right?
Yes.
So where is that X? Where is that A here? A direction from X. 40 degrees from X, right?
Yes.
So where is that here? Where is that here?
80 degrees from X.
That X 80 degrees. So 80 degrees, 80 plus 33, that one must be 110, more than 90 degrees there, 110 somewhere there. So this is 80 degrees there. Are you with me?
Yes.
So that point is what? A, right? So from horizontal here, not horizontal XY. X is that. From horizontal more circle here, what is the angle there? 80 plus 33, right? Are you saying 113, right?
Yes.
This angle here is 113. 113.7. So that is your position of X from A, 80 degrees. Or from 1 here is 113. Same thing here. Where is your A position? Your A position must be there. A. So that is 113. So where A there, can I read my value of stress A there? Yes, draw the triangle there. Find the B in the center minus B. The sigma A is equal to center minus B. Triangle there. You must know the angle there. 180 minus 113. Are you with me, guys?
Yes.
So can I find the stress in that direction? So that is how you convert from stress to strain. Strain to stress and stress to strain. Are you with me, everybody?
Yes.
This is very important. Because it summarizes the whole stress analysis and strain analysis. Are you clear with me?
Yes.
Okay, I want you to do the same exercise that we learned today. I give you some exercise, homework, and then we can do some more later on. Okay?
Okay.
Okay, guys. Thank you very much. Assalamualaikum.
Thank you, doctor.
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 Thank you, doctor.